We will now proceed to explore PLC programming for commercial dishwasher control logic. Understand the dishwasher control logic. Familiarize with components. Start by identifying the key parts of the dishwasher, such as water pumps, heaters, sprayers, valves, and temperature sensors. Additionally, understand the system's user interface and any safety features like door switches. Identify inputs and outputs. The inputs include sensors, like water level sensors, temperature sensors, switches, like start-stop buttons, door switches, and timers. The outputs control the motors for pumps, heaters for water, solenoid valves for detergent, and indicator lights. Understand the sequence. Know how the dishwasher functions step by step. For example, the process might involve filling the tank, heating water, running a wash cycle, rinsing, and finally draining the water. Each of these steps will require coordinated control of multiple components. Develop a flowchart of the control logic. Create a visual flowchart. The control logic should be outlined as a flowchart to visually represent how the dishwasher will operate. This is a diagram showing the sequence of steps, starting from power on to the completion of the wash and rinse cycles. Map sequence of events. Define what happens after each action. For example, after pressing Start, the system might fill the tank with water until the level sensor is activated, then heat the water to the required temperature. Include decision points. Add branches in the flowchart where decisions must be made based on inputs. For instance, if the water temperature reaches a certain point, the heater turns off and the wash cycle begins. Implement the program on the PLC. Upload the program. Once the program is tested, upload it to the physical PLC connected to the dishwasher. Ensure that you follow proper procedures for downloading the program into the PLC to avoid any disruption. Verify connections. Double-check that all wiring and connections between the PLC and dishwasher components, inputs and outputs, are correct. Incorrect wiring could cause component failure or improper system operation. Test with the dishwasher. Test the program on the actual dishwasher. For example, start the wash cycle and ensure all motors, valves, and sensors work correctly as per the logic programmed. Write the PLC program. Use PLC software. You will need software such as Siemens TIA Portal, Allen Bradley RS Logix, or Mitsubishi GX Works to write the PLC program. Translate flowchart to code. Convert the flowchart into a PLC programming language. Ladder logic is commonly used for PLC programming because it resembles electrical relay logic. Each element in the flowchart, such as a valve opening or a motor starting, corresponds to a rung or block in the ladder logic. Virtual testing. Before uploading the program to the hardware, test it virtually using simulation tools available in most PLC programming environments. This helps ensure the program functions as expected without risking damage to actual components. Document the program. Detailed documentation. Ensure you document the entire program, explaining how it works, including the control flow, inputs, sensors, switches, and outputs, motors, valves, etc. Maintenance notes. Include troubleshooting steps and any changes or updates made during the development phase. This will help anyone maintaining or modifying the system in the future. Version control. If there are any updates to the system, ensure the documentation is updated accordingly. Always keep a record of the program version and date of any modifications. Perform system integration. Integrate with other systems. In a commercial kitchen, the dishwasher may need to work in harmony with other equipment like water softeners, detergent dispensers, or even an energy management system. Ensure communication. If there are other PLC-controlled devices in the kitchen, make sure they can communicate with each other. For instance, A central PLC might coordinate when to start the dishwasher cycle based on kitchen activity. Test integration. After integrating, run tests to make sure the dishwasher operates properly in conjunction with other equipment. Ensure no interference or conflicts occur between systems during operation. Debug and troubleshoot. Identify errors. If the dishwasher doesn't operate as expected, use PLC diagnostic tools to monitor inputs and outputs. Check for signals from sensors and verify if the control logic activates the correct outputs. Troubleshooting. Fix any bugs or logical errors that could cause the machine to malfunction, e.g., a water pump running too long or the heater not turning off. Use tools such as online editing in PLC software to make real-time corrections. Optimize performance. Adjust the control logic to improve efficiency. For instance, tweaking the timing of operations to reduce water consumption or cycle time. By following these steps, you can effectively program a PLC for controlling a commercial dishwasher, ensuring that it operates efficiently, safely, and meets the operational requirements of a busy kitchen. Thank you.